This is a DeepSpace storage companion video to our QuickStart guide for CEPH environments. Jumping to page 2, we're going to go over the prerequisites. I've installed this system using the CentOS 7.9 image, selecting the server with GUI configuration option. I did not choose to select any other packages, just the default server with GUI. This system is configured with 32 gig of memory. That's only because it's also running the relational database management system. If this machine were a file system client, I wouldn't hesitate to install on a machine with much less memory. The processor configuration is a 4-core, 4-thread at 3.2 gigahertz Intel i5, so nothing exotic. I have configured a couple of test file systems. They're native XFS file systems, and there were no special mount options. We get our file system events using the upstream kernel's FA notify library, which has been part of the kernel for quite a few years, so you shouldn't have any compatibility problems running a much earlier version of CentOS. We do not support 8.0 yet. That requires a port due to some externalities with regard to RPC, but just telling you, don't bother trying it, it won't work. I've not yet installed the CEPH client on this machine, so we'll do that now. The CEPH common package is the only one that we need since we attach to the cluster using librados. Once that package is installed, I'll need the configuration and the keystring files. So I'm just going to copy those over. And what I'm going to do is I'm going to copy the entire contents of etc CEPH on my mod machine into my local etc CEPH subdirectory. Then to check for connectivity, we can run ceph-s, and it shows I'm connected to a healthy cluster. When I installed this machine, I followed up by doing an update and editing the etc SE Linux config file to disable SE Linux by changing permissive to disabled. Running the SE status command confirms status set. I also, before doing a reboot, did a disable of firewall D. You can confirm that by doing system cuddle status. And as you can see, it is disabled. Now we'll move on to installing SaltStack. In order to make the configuration as simple as possible, I put an alias in my host file so that my local host named Alfalfa also has an alias to Salt. Now, the easiest way to install Salt is to pull down their installer from the SaltStack website. We'll do that using curl. And then run it. The -p-m options install both the Salt master and the Salt minion at the same time. Now, in addition to the change that we made to etc host, I have just one other file that we need to modify, and that's etc salt master. And you just want to come down to the line that starts with interface, remove the comment, and change the IP address to this server's IP address. And we'll save that. And we'll use systemctl to start master. And systemctl enable the master so that it starts on reboot. And we'll do the same thing with a minion. Then the last step is to handle the initial key exchange. So we'll run the salt key command with -L to list. And you'll see that alfalfa is unaccepted. So we'll take care of that with salt key -A. And lastly, we'll do a test ping just to make sure everything is working. If that comes back as true, we're good to go. Now we'll need to configure the DeepSpace repo in order to install our software. I've already done that. As you can see, I just copied directly out of the QuickStart guide for those 4 packages: the catalog manager, SMS user interface, SMS, and system monitoring facility. So now we'll go ahead and install those. We're not going to configure DSCM yet, but we need to install the package because there are some files that we'll need for the database. And we're going to be doing that step next. So we'll move on to yum install MariaDB server. And then systemctl start and systemctl enable MariaDB. And then we'll run the MySQL secure installation. You'll have no initial password, so just carriage return here. We definitely want to set the password. This is the database root user password. So set that to something that you'll remember because we're going to be using it a lot in the next steps. Remove anonymous users, except the default. This is the database user, root user, login remote. The default is to remove it. I prefer to leave it. If you do want to remove it, you can. It'll affect one step that we're going to get to in a moment. But I'm just going to answer no. And then accept the defaults. And we can move on to the etc mycnf.d mycnf file, which has got some database options that we want to set. So from here, we can copy and paste directly from the manual. There is one line that you will need to customize for your system, and that is the amount of memory that we allocate for the InnoDB buffer pool. We recommend that to be between 50 and 70% of the installed system memory. This machine, as I said, has got 32 gig of memory. So 70% of that rounded down is 22 gig. I'm just going to change that and save the file. Now, one of those files that we installed with the DSCM package was the init.sql file. So we just need to copy that in place. And we're copying it into your MariaDB data directory, which in a default installation is var lib mysql. And at this point, we can restart the database so those changes will take effect. And the next thing to do is create your credentials file. That is saved in etc my.cnf.d as ds.cnf. So I've already created that file. Just point out a couple of things. There are 3 user accounts we need to set up. I'm using the string localhost to identify the host. That could be alfalfa instead. But in the next step where we create the accounts, whatever you put in for this string, you have to also use when you create the account. Also, you want to go with a more complex password than password 1234. So here we'll create the 3 accounts, starting with DSCM. Remember that the @ host string has to match what you put in the ds.cnf file. And also remember, your password also has to match. And here again, we've got the localhost. So all those have to match ds.cnf. So we'll create the first account, which is for the catalog service. And here's where we use the root database user account that we entered during the secure installation script. And then we'll grant privileges. Again, note the local host here. If you used an actual host name, you'll have to change it to whatever you used. Likewise with the password. Enter whatever you put into the ds.cnf file. So that's the catalog manager user account. Next, we'll do the SMF user account. And again, database root user password. And we'll grant privileges. Again, adjust your host string and your password string to match your ds.cnf entry. And lastly, SMS, Systems Managed Storage. That user account will create now. Again, adjusting localhost to whatever you have in your ds.cnf file. And again, grant privileges. And once all 3 of these are created, we'll run flush privileges. Now we need to create some tables. So we'll change directories into our SQL's directory. And first we'll create the catalog managers tables. Now here I'm entering the host name instead of localhost. This will only work because I did not disable remote root login. If you had, you'd have to put localhost in here. And then in that same directory, we're going to create the SMF database and table. That's the last of the configuration steps for the database, so we'll move on to confirming that we set everything correctly and all the credentials work for the 3 users and we can log in using them. So first do a status on MariaDB and you'll find that it is active and it is enabled. So we'll go through the 3 user accounts, log into each one, and make sure that the password that we put in the ds.cnf file gets us access to the account. Now we want to do a show tables from here, and we should see 17 rows returned. We'll quit out of there or exit out. And next we'll try and log into the SMF DB using the SMF user account. And we'll show tables again. And you should just see the one SMF table. And then we exit. And then the last account is the SMS user ID, and he does not yet have a database created, so we'll do that. We'll do that by creating the database with the create database SMSDB command. And then we'll exit out of that account. Now it's time to install and configure the catalog service. So we're going to cd to the user local ds subdirectory and run the ds install command. We'll want to accept all the defaults here. Where it requests yes or no response, you have to give it a yes. There is no default for those. And now our installation is complete, except for adding the logical drives, which we'll do next. But first, we need RPC running. So we'll do a systemctl enable RPC bind and start it. And then we'll start the DSD service, which is the catalog service. and enable it on reboot. Now at this point, you'll really want to have your path set to include user local bin for the root user. So let's cd to the back to the root home directory, and we'll edit the dat.bash rc file by just adding export path equals $path and user local bin. Then we'll save that, and we'll source it into the current shell with a dot space followed by the bash rc command. So now user local bin should be part of our path, and if we run the ds command, it will confirm that it is in the path and our servers are all up. So now we'll create the logical drives that we use to communicate to the Ceph cluster. That created 20 drives, and we'll have to do a restart of the catalog service to initialize them. All right, it's time to move on to a test of the catalog service, but before we can do that, there's a couple of steps we need to do. We need to make a Rados pool, and a couple of things I want to point out here. First of all, this is not the optimal way of doing it because I'm not specifying placement groups. I can't do that at this point for your system because it's determined by your cluster configuration. So this will come up with a non-optimal and result in warnings that you have too many or too few placement groups. That's okay. It doesn't stop anything from working, but you should change this command for your environment just to avoid those annoying warnings. Also, the name of the pool, we set the ownership as root, and I use the convention of the host name followed by P. So you should also use root / some string, but the string is up to you. It just needs to be unique per DS instance, not per host, but per catalog instance. The next thing that we need to do to avoid warnings is to enable that pool for an application. And you can use any string that you like. I'm using DeepSpace CDS. Now that we have the pool configured in the Ceph cluster, we need to create the same pool in the catalog service. And of course, the string that we use has to match what we did when we created the pool in the Ceph cluster. Then the next thing is to create scratch volumes. I'm going to create 100,000. This will take anywhere from 5 to 20 seconds, depending on the performance of your database server. And now we can run a DS report --vlist. And as you can see, we have 100,000, and they are of the Rados type, and they are set to the correct pool. So now it's time to create a volume set in the catalog service. And note that the pool name is specified, so you will have to adjust this command line for your configuration. The next thing we do is access the volume set. Since this is the first time and it's blank, we have to access it with right equals yes. It will fail without that option. And then we will write a file to it. Now we can run the ds report command with volume set file list. And as you can see, it shows the one file. So let's try and do a read on that file. And then we'll do a diff to compare that file against the original file that we wrote. As you can see, they're the same. Now we want to free that volume set. And we'll go ahead and scratch it. Now it's time to move on to installing SMS. So we'll do a yum clean expire cache. And we'll install DSFS for the XFS file system using the FA notify curl library. Now, note this is a new installation, so we need to run this init script. And the last step we have to do is install our graphical user interface, which is yum install dashboard. Now we'll do a system cuddle status dashboard. And if it comes up and it says active and enabled, we're good to go.